Okay student, there was a power cut in between, so hence I have to stop there. So we'll continue again. So what I was saying, that the uncombined oxygen and nitrogen dioxide, what it does, it goes to the catalytic chamber, then to the cooling fins, then to the oxidation chamber, and finally it comes here in the absorption tower. What I said you, absorption tower is being packed with quartz, the water is being sprayed from above, the gas goes below, and after that the gas rises. Why quartz is used? Because quartz is acid resistant and it slows down the movement of nitrogen dioxide and oxygen. It slows down, due to which easy dissolution or easy solvation of nitrogen dioxide takes place with oxygen and water to form nitric acid. Got it? In this way nitric acid is being formed ultimately. But the acid which you are getting it here, it's being collected at the bottom and the base, and we are collecting from a tap here. You can see a tap is there and we are getting it from the tap. But remember that the nitric acid which we got it is a dilute nitric acid. Definitely we got a dilute nitric acid. Alright, 50% what you can say nitric acid and 50% water is there. It's a dilute nitric acid basically. We got it. Now you will say, sir, now I want a concentrated nitric acid. I need a concentrated nitric acid. So what I have to do? What if I need a concentrated nitric acid? Very simple. Just you boil it, this solution. Just you boil it. Simply boil it, nothing else. On boiling, what will happen? Water is going to evaporate, leaving behind nitric acid. But by this, how much percent concentration you can increase to? From 50 it comes to 68% when the temperature reaches 121 degree Celsius. Now beyond this it is not possible. 68% nitric acid you will be getting it. Means the concentration will be 68%. When the temperature reaches 121 degree centigrade, the concentration increases from 50% to 68%. Beyond that it is not possible. Why it is not possible? Because it forms a constant boiling mixture. I told you earlier also, in HCl ammonia, it forms a constant boiling mixture. So in constant boiling mixture, what will happen? So not only after 68%, what will happen? Not only water will evaporate, but also at the same time nitric acid is going to vaporize out. Not only water is going to vaporize out, but also nitric acid is going to vaporize out. What is the use? I want nitric acid to be concentrated. So I want water to be vaporized, not nitric acid. So for that reason, I can do it up to 68% when the temperature reaches 121 degrees centigrade, because there it forms a constant boiling mixture. Constant boiling mixture is a mixture which has this which boils like a pure component without any change in its composition. It boils like a pure component. Yes, it boils like a pure component. It is boiling, alright, and its water is evaporating and acid is leaving behind. Now you will say that can't we get the pure nitric acid? Let us say 98% and 99%. Yes, we can get it. Then what you need to do? You will boil it. Listen carefully. You will boil it under reduced pressure in presence of concentrated sulfuric acid. You will be boiling it. Why? Because conc H2SO4, you know, it's a dehydrating agent. Under reduced pressure, alright, under reduced pressure, you will be boiling it, because the pressure, what you can say, will be reduced, and the boiling point also will be reduced. We can say that. Clear? Under reduced pressure, you will be going to boil it in presence of concentrated sulfuric acid, where water will evaporate, leaving behind what you can say nitric acid. We can say that. Clear? Because concentrated sulfuric acid acts as a dehydrating agent. And how much percentage you will be getting it? You will be getting it maximum up to 98%. We will be considering this as 100% only. And this nitric acid is considered to be as fuming nitric acid. We can say that. Fuming nitric acid, which is 98% concentrated, I should say. Alright, when you will be boiling it under reduced pressure in presence of concentrated sulfuric acid. From 68% it comes down to 98%, we can say that. Clear? In this way we will be, that is, making the acid concentrated. Now remember that if you see the properties, now this was your post-work process. Now if you see the properties of nitric acid, the nitric acid vapors are highly suffocating. Highly suffocating, definitely, because it cuts off the oxygen supply. And next is that it is sour in taste. Acid, it is sour in taste. But pure nitric acid is colorless. But remember that pure nitric acid is unstable in nature. Remember it. Pure nitric acid is unstable. It is colorless, it is unstable. But commercially prepared nitric acid which are available in the lab, it is not colorless. It is slightly pale yellow in color. Do you know why it is? What is the reason behind it? It is nothing but due to the presence of dissolved nitrogen dioxide gas in it. Due to the presence of dissolved nitrogen dioxide gas in it. For that reason, you have seen it in the lab, the nitric acid is not kept in an ordinary glass bottle, plain glass bottles. It is being kept in a dark colored glass bottles because in presence of sunlight, in presence of room temperature, also nitric acid decomposes slightly. That is, HNO3 will decompose to give you NO2 plus O2 plus water. It is going to decompose. Alright? The way it is being formed, the same reaction is going to take place. In presence of room temperature, that is in presence of light and air, nitric acid decomposes to give this. And nitrogen dioxide, you know, is reddish brown color. This reddish brown colored gas, when it dissolves in nitric acid, it gives a slight yellowish tinge to the nitric acid. For that reason I said pure nitric acid is colorless, but commercially prepared nitric acid is slightly pale in color, and hence the nitric acid which you are getting in the lab, that is commercially prepared nitric acid, you are getting it in the lab. Because pure means you have to prepare it immediately and you have to use it. Now in the lab, are you having the apparatus to prepare nitric acid? Are you having all those things? No, you don't have, isn't it? We are getting it, we are buying it nitric acid. So the nitric acid we are buying it, which is slightly pale due to the dissolution of nitrogen dioxide gas in it. We can say that. Clear? Now the question you may ask me, sir, can't we remove this particular gas? Yes, you can remove it. You can remove the gas. What you need to do is that you need to, what you can say, heat. Heating will do, yes. On heating and also passing air through it under pressure. When we will be slightly heating it, slightly we will warm it and will pass air under high pressure. What will happen is that the air will take the place of nitrogen dioxide. It will push the NO2 gas outside. So NO2 will be evolved and oxygen will get in. Oxygen is colorless. It will remove the yellowish tinge. In this way, yellowish tinge can be removed. Alright, understood what I said? Simple it is, just warm it slightly and pass air under high pressure. Air, what it will replace the nitrogen dioxide gas. It will force the nitrogen dioxide gas to come out of, what you can say, this nitric acid, and as a result nitrogen dioxide gas will be evolved and oxygen will take its place, and oxygen is a colorless gas, due to which the yellowish tinge can be removed. Or another way is also there, that you add some more water to it. By adding water, what will happen? Nitrogen dioxide gas will dissolve in it, in that excess water, and the yellowish tinge can be removed. In this way, you can remove the yellowish tinge of nitric acid. But remember it, pure nitric acid is colorless, but it is unstable in nature because it decomposes. Alright, so hence for that particular purpose in the lab, we keep nitric acid in a dark colored bottles. Basically, it is avoided away from sunlight. It is being avoided. So generally we keep it in cupboard. That is a box is there, you can see in the lab. There we keep the nitric acid. And if you keep it outside the nitric acid, you will find it is pale yellow colored nitric acid. You will be getting it. The reason is what I said it to you. Alright, and nitric acid is acidic in nature. It will give the test for acid. What test? It turns litmus red. Phenolphthalein, what you can say, it remains colorless. Methyl orange, it turns pink. You know that, all those things. Alright, nitric acid is a monobasic acid. How can we say it is a monobasic acid? Because nitric acid dissociates to give you one H plus ion. Alright, nitric acid. But remember that it should be dilute nitric acid. Remember that it should be dilute. Nothing is written means it's dilute, not concentrated. Because concentrated nitric acid is an oxidizing agent. Why? Because concentrated nitric acid does not, what you can say, dissociate into its ions. It's a covalent compound. Remember it. Listen carefully. Concentrated nitric acid, it does not give H plus ions. Got it? It's a covalent substance. It decomposes to give you nascent oxygen, and nascent oxygen helps in what? Oxidation. So remember it. Concentrated nitric acid acts as an oxidizing agent. Even dilute nitric acid also will act as an oxidizing agent. But how? See. So here nitric acid, basically I was talking to you dilute, it will give you H plus plus NO3 minus. This H plus ion says what? That nitric acid is a monobasic acid. Monobasic acid. How can we say? See, NaOH, when it reacts with HNO3, it gives you NaNO3 plus water. This is a reaction of acid we studied. This is a reaction of acid we studied. Similarly, if you take here calcium carbonate, CaCO3 plus HNO3, what you will get? You will get CaNO3 whole twice, because calcium valence is 2, CaNO3 whole twice. So I will put it here 2. So hence what you will get? See here, Ca is gone, NO3 is gone. So CaNO3 whole twice. What it remains? Here 2H and CO3. So it will form H2CO3. But H2CO3, again carbonic acid, is unstable. It will decompose to give you water and carbon dioxide. So I said, all these are double decomposition reactions. See here, plus minus. This is not a valency. I am writing the charge only to explain double decomposition. This is plus minus. So this plus goes with this minus and this plus goes with this minus. That's it. It's a double decomposition reaction. Ions are interchanged. Finished. Got it? So in this way you take calcium carbonate, you take what you can say, let us take it as nothing but zinc sulfide, ZnSO3 plus HNO3 if I take. Can you tell me what is going to happen? Double decomposition. Do it. Zinc nitrate, ZnNO3 whole twice. So here I'll put it as 2. Now H2SO3. H2SO3 again same thing, unstable. It will give you H2O plus SO2. That's it. Very simple. In this way, these are reactions you studied in acid basis salt. So in this way, it gives you this particular reactions. Now I was saying to you that concentrated nitric acid is an oxidizing agent. Yes, it's an oxidizing agent because it does not decompose in this manner. It will not give you H plus ion, concentrated nitric acid. It will give you what? Nascent oxygen, concentrated nitric acid. HNO3 will decompose to give you NO2 plus water plus nascent oxygen. But again I added there that dilute nitric acid also is an oxidizing agent. Dilute nitric acid is also an oxidizing agent. Why dilute nitric acid oxidizing agent? Because in case of dilute nitric acid, NO3 minus decomposes to give you nascent oxygen. Now it's clear how dilute nitric acid is an oxidizing agent. So dilute nitric acid not only acts as an acid because it liberates H plus ion and it gives you this all reaction. So many other reactions also we can write. But at the same time, nitrate ion decomposes to give you nascent oxygen, due to which dilute nitric acid also acts as an oxidizing agent. But concentrated, no chance. Concentrated, due to the absence of water, does not dissociate into its ions. You know why dilute nitric acid decomposes into H plus ions? You have studied. Water, which has got high dielectric constant, it dissociates nitric acid into its ions. It helps to dissociate, due to which we are getting H plus ions. But when we say concentrated nitric acid, are we having water? No. Because it's a covalent substance. It will act as an only oxidizing agent. It will not act as an acid. Got it? So understood some of the properties of nitric acid which I said it to you? Thank you very much.